Raise your hand if you have this entered in your calculator, please. Awesome. The next step is this. On the AP Calculus test, any final decimal answer must be rounded correctly to 3 or more decimals. So we'll just practice using 3. So if you have an 84, you'll want to hit the mode button. And make sure your answer mode is in decimal form. So kind of practice doing the rounding. And then up here on where it says float, we can change this to do 3 fixed decimals. So we can come down like this. Set that at 3. Does anyone have a question? Yes. Yes.
Do you know how to change it to decimal?
Hold on. Anyone else in the room have an 89? Oh, very good. Do you know how? Yeah. That's always option 1. Option 1. I want it on fixed 3 is what you want.
Oh, so.
And then we can make snow angels, and then decorate gingerbread houses, and then maybe go ice skating. That's kind of what I would base it on, right? That's kind of hard mode.
You ever play hard mode?
Yeah.
Do you like it better?
It was his birthday.
Anyone else? Awesome. You struggle.
You look like you're struggling.
Randy, oh, get there. You good?
Yes.
Okay. No worries. It's a really good calculator. It just works differently, so you just have to find it. All right. So then you say second quit. Okay, basically what we want to do is we want to take the equation in y1 and we want to plug in different values of time. So you're going to get alpha F4. And there's the list. I need y1. It's just like function notation, so it's not multiplied. It's y1 of value of, like 0 is what I did before. There it is.
Why is this so rough?
So on the 83, what you do instead,
Comes up with a graph.
on the 83, what you do instead is you have the bars key.
Hey, I got a different answer.
The bars key. Choose the y variables. Then you choose function, and it gives you the same list. From there, it's the same. If you're getting a different answer, it means your equation was entered incorrectly. Anyone need help? Rest of them. Oh, yeah. Did you have this last night? Work last night. Everybody's loaded this weird program. We always talked about how to get good at stuff with the you want to remember how certification should be tested. Oh, because the character expression is so it's the Y1 part text value of 1.
Sorry.
Randy, you know?
Yeah, I'm just gonna use one of your calculators. It's really hard. I might just go fine.
Y1
Yeah.
Why do you rank it order on your 10
On my what?
On your 10
Terrarium? It smells good. It does actually smell good. We are cleaning the evil spirits from our table. There's no evil spirits in I know.
You never know.
Brand new. We are so special. We have aesthetic. It's a pretzel goldfish. Don't get it. Try it. Ready? Try it. It's good. Very good. Do it under. It's contaminated.
Where did it go?
Oh, it's okay. I was just trying to drop that. Thanks. I took the AP Lit test and it was a big deal, and so I wore my yellow lucky shoes. My lucky yellow.
Did you pass that?
What?
Right, so guess what?
You did.
Guess what color guess what object is also like your shoes? I was gonna say the sun, but the draft.
Victor, what AP classes did you take last year?
What? You should play football like you're
I know.
You wanted to play football?
Have I ever wanted to? I think it'd be fun to tackle. I've ever
Don't throw at such tiny velocities, I can't even compensate.
Rachel, where do you want to go? I'm not
I will probably.
Okay. I'll give you a T minus 10.
But I like what you feel last. When you start taking back. Don't know.
Actually,
I can't remember, but
You're gonna be an engineer.
I don't know really what it is. But it's not like.
why did you play football?
We did.
Wait, so why did you
You're good. You're kind of like David. You don't get offensive.
Thanks.
Hey, you could have come. Dude, Justin left.
Then she, I do like 3 or 4 safeties. Like make fun of.
No, she sprained her shoulder. Wasn't that bad.
Is that mine? Oh, because Ava's from what? So she's 4? Okay.
That doesn't even make sense. Sent Tad a picture, a selfie stick, said, hey babe, what's your number? He said, how does my
I'm
What we did is
My what?
We figured it out.
Are they real?
Because I don't want to be doing
well, they might.
Oh!
Thank you.
Richard, do you have all 4 listed, please? Show me your hand. Oh, yeah. Do all 4. Go, go, go.
I deleted it.
Good, good, good. Let him catch up. Well done.
Let me teach you something. It's all the
Yeah, so it's a video.
Always round to 3 decimals. Okay. Yep.
You're like,
Oh, so that's like a problem, it's like that's a problem.
Yeah, yeah, I want you to find what you got with your calculator. I didn't say the quiz was hard, I just said this is the quiz. Well, so far, yes.
holy cow.
Calls on guard now. She's not like. Oh, yeah, you were gone. Kids will explain. Hey, hands up if you have this. Who has this done? Come on, show me your hands. Show me your hands. Okay, so Spencer, what's the first one?
X of 1.
Uh-huh.
-2.667.
You need to always practice rounding to 3 decimals because the AP test requires it. If you don't correctly round to 3 decimals or more, you lose points. Okay? How many got that? Please show me your hands. Show me your hands. Give yourself 2 tickets. Spencer gets 3 for being the voice. Question, Garrett?
Nope.
Nope.
I
Okay.
just switched with it.
This is the last day for a massive ticket giveaway. Then we'll turn them all in at the end of the period today. So.
So, Mine did a fraction instead of.
Right, so do this, Sierra, on your calculator.
Explain this to us.
Hit the mode button.
Okay.
Scroll down until it says answer.
Okay.
Change it from auto to decimal.
Okay.
Try that.
Okay, thank you.
No worries.
Okay, guys.
Hands up, who has the next one? Okay, come on, who has the next one? Refocus, Autumn, what you get?
Negative 4 points.
Who has that? Please show me, come on, who has it? 2, 3 for Autumn. The third one, who has it? Listen, sorry.
Negative 2.00.
No worries, great comment. 4 for Alyssa. If the value is perfect, exact, then you don't have to include any decimals. We're good. So just negative 2 is fine. When you do it on your calculator, does it mean negative 2.00, just say negative 2? Oh, interesting. Okay. How's this one? Let's go, Nathan.
6.333.
Somebody got that? 2 points, 3 for Nathan. Anyone have a question? Anyone? Okay, good. Next thing, please write on your paper, this is part of the quiz as well. Write the answer to this question. So what does x of 3 equal negative 2 mean? Like, what would be an English sentence?
Do we have to write the actual question now?
You don't have to write the question. What does x of 3 equal negative 2 mean? Just write an English phrase or sentence describing the meaning of this mathematical sentence. What does x of 3 equal negative 2 mean? I realize that this is not off the yellow sheet, but I thought no one would complain since they're not very difficult questions. Hands up if you have it. Give it a minute, but good try. Hands up if you have it. A minute, still writing a little bit. Hands up if you have it again. Show me your hands. Who has it? Who has it? Who has it? Randy, read me what you wrote.
I wrote such as the y and also be negative 6.
No, I give you credit for that. That's fine. The context they want is more, there's nothing wrong with that, so that's not wrong. The context they want is in the context of what x of t means. So somebody help me. We talked about this last time. When you see a formula x of t, what is the formula x of t describing? Yeah, that's what we want to be thinking. No worries. So when time is equal to 3, the particle is at a position of negative 2. How many had something like that, please?
Oh,
2 points, 3 for Tyler.
I had like at the x coordinate of 3, the y coordinate would be negative 2.
No, I give you credit for that as well,
Okay.
because the question's a little bit open.
Yeah.
No worries. The one I was hoping you would say is what Tyler said, but that's fine. Other question?
In terms of the equation.
Yeah,
top, that
no
makes
worries,
sense.
no worries. You answered it perfectly, so please, Martha.
Is it okay that it says that 3 is the horizontal value and negative 2 is
That would be fine as well. Yeah, good answer. Good answer. Anybody else? Okay, next quiz question. Hey, next quiz question. Answer this. What symbol represents the derivative x of t? What symbol represents the derivative of x of t? Write that down, please. There could be multiple answers on this one as well. What symbol is used to represent the derivative of x of t? You don't have to be, I mean, several answers are correct here, you just gotta have one of them. This one is off the gold sheet, the yellow sheet. What symbol represents the derivative of x of t? So hands up, who has it? Yeah, who has it? Matt, what'd you get?
X prime of t.
So Matt said x prime of t. That would be correct as far as the quiz is concerned. Perfect. Anybody else? Colin? Colin says v of t. Anyone else? Perfect. How many got it right? Yeah. 2 tickets, 3 for Colin. Also off the yellow sheet. Just write it down, please. What is the English word that this symbol represents? Just write the English word. Write it down. What's the English word that this symbol represents? It was very difficult today. So hands up if you got that one. Show me. Bryce, what did you get?
Velocity.
Bryce says velocity. How many got it? 2, 3 for Bryce. Got to keep finding excuses to give away tickets. Last day to turn them in. So do we have a question? Awesome. So we got all that figured out. So now we draw question for the quiz. Write this down, please. The answer is always, I'll give you the answer is either going to be left. No, so the answer is going to be left and right, up and down, or both. So there's 3 possible answers. Left and right, up and down, or both. So my question is, when we are talking about a problem that describes the position of a particle, and they use this symbol, x of t equals, are they referring to a particle that moves back and forth? Or are they referring to a particle that moves up and down? Or are they referring to a particle that moves in a complex way, meaning both left and up, or right and down? Write down the answer, please. What are they referring to when they say this? Hands up, who has it? Ashley, would you get it? Ashley says it's a particle that's moving left and right, or back and forth, sometimes we say. How many agree? 2, 3 for Ashley. Any have a question, maybe?
Wouldn't it be left and right, or up and down, but not both?
Good question. I'll give you credit for that on the quiz, because the way you're asking it's very good. Typically on the AP test, if they say a particle is moving back and forth, the symbol they will use to describe that motion is either x of t, or they'll sometimes use s of t. If the particle is moving up and down, they'll typically use y of t. Does that make sense? So they won't use this for motion that's going. Anyone else? Awesome. Okay, so we know we have all those positions. We know that it's the velocity. We know it's the particle going back and forth. Therefore, we can draw. Please put this in your notes. Okay. Put this in your notes, please. Draw a line. There's a spot on the line. This is not from the gold sheet. This is from your work last time. You need to look in your notes to answer this question. I'm okay with it today. This isn't generally true on a quiz. There's a special name. Like, we're talking about a particle moving back and forth along some sort of straight surface. There's a reference point, 0. We call that position 0. But there's a special name that you encounter on AP test problems that refers to this location. Write down that name, please. Like, draw this, and you're going to write the name right here so you don't forget it. Write down the name of that special location, position 0, the word they will use on an AP test question. So, who's got it? Hands, please. Let's go, Danielle.
The origin.
We refer to this as the origin. have that? 2.3 for Danielle. So now we can plot other points here. We can say at time equal 0. Please put this in your notes. Here's the particle, and that's position 1. Then we know that at time equal 1, particle has moved over somewhere about here-ish, I don't know. Negative 2.667. This is time equal 1. One person answered this question. Based on the information that is on the board, do we know if the particle went, watch this, do we know if the particle went like this? If the particle only goes left and right, it doesn't go up here, just left and right. Do we know if the particle went to the right first, and then back to end up here at time equal 1? Or do we know that the particle started at time equal 0 and went directly to time equal 1? Or perhaps the particle even did this. Right first, left, and then back to time equal 1. Do we know that the particle did that based on this information? Somebody raise your hand and comment. Garrett?
We don't know because that's just like one point on a infinite time scale pretty much, so it could have gone anywhere.
Well said. I've heard people say this. It's kind of like you see the particle here, then you turn off the lights. And 1 second later, you turn the lights on, and the particle's here. And you don't have any idea of how it moved from here to here, other than we have stated that the rules are it must go simply left and right. Does that make sense? 3 for Garrett. We have a question. Cool. So you can plot the other points. Please put these in your notes. Come over here to time equal 2. Negative 4.333. Time equal 3, so I kind of squish it in here. That's position negative 2. This is t equal 3. And then our scale's a little off, but close enough. Over here is 6.333. And that's the particle's position when time is equal to 4. Have a question? Awesome. Okay, new question for the quiz. This one, because it's not on the gold sheet, I'll let you work together. Talk to as many people as you want. I would love to get everyone to have the right answer so I can pay everyone tickets. Plus you get the quiz points. I want to know the answer to this question. From time equals 0 to time equal 2, by how much does the position of the particle change? By how much does the position of the particle change? That word it's a key word. It shows up on the AP test regularly. They'll want to know the change in the position of the particle. So the particle is sitting somewhere at time equals 0. Turn off the lights. The particle does something. Turn the lights back on. The particle has a new position. You don't care how the particle moved. All you care is how much did the position change. So if you can answer that question alone or with help, please write it down. Right here, please. How much did the position of the particle change? If you'd like to talk to other people, feel free. Now, normally on a quiz, you won't get help from anyone else. But this one's okay. If it feels simple, it is.
If I give
Yeah, Alyssa is right. I don't really care too much about the positive and negative yet. We will eventually, but if you get that backwards, I don't really care. So, who has an answer, please? Show me your hands. Show me your hands. Show me your hands. Who has an answer? Who has an answer? Let's go, Sage. 5.333. And it actually is referred to as being negative so that we can know that the particle's position changed to the left. So the negative on the AP test is important. If you miss the negative part, it's okay. So that's the amount by which the particle's position changes. How many got that? Show me that. 2 points, 3%. Another question. Show me one or two that makes perfect sense. One or two that makes perfect sense. Everyone give yourself 2 tickets. Here's what we did. They look up here. Hey, you people were a little confused. Notice, when you start, in fact, let's do this. The whole class, I'll give away as many tickets as you can stay with me. So this is the origin. Watch me. I'm the particle. Okay, here's the origin. I'm right now at position 3. Got it? I'm at position 3. You turn off the lights. Boom. I move around. I'm now at position -1. Raise your hand if you can tell me by how much did my position change. Hands up, come on. By how much did my position just change? My position during that time period. Mariana. Mariana says -4. How many got it? 2 points. 3 for Mariana. Here's another one. My current position is -1. I go 1, 2, 3. My new position is -4. Raise your hand, you can tell me by how much did my position change? By how much did my position change? Let's go, Heather. Heather says -3. How many agree? 2 tickets, 3 for Heather. The same thing happened up here. Look, the particle was at a position of 1. It ended up over here. So how much did the position change? Well, to get back to the origin was 1. And then to get to over here was another 4.333. But because it started here and ended up left, we say its position changed by -5.333. The mathematical computation, which you will do in the future, it looks like this. You would say the position at time 2, subtract the position at time 0, which is equal to 1 subtract. No, sorry, did that backwards. Back out. It's equal to -4.333. Subtract 1, that's -5.333. That's how we compute the particles change in position. I'll give you 1 or 2 if that makes perfect sense. 1 or 2 if that makes perfect sense. Kind of keep going. Let's get 2 more tickets. I have a question. Oh, please.
So is it like the final position, like the start to the beginning? Or is it like in between? Because how do we know that the particle didn't go like right first and then left?
Oh, outstanding question. Great ticket giveaway today, so we give Ashley 5 for an outstanding question. Ashley, you'll answer it yourself. The particle could have gone 10 this way, 10 back, and then ended up here, which means it would have traveled a total distance of 10 plus 10 is 20, plus the 5, so it would have gone 25.333. Everyone hear this? The test will refer to that as the total distance traveled. Okay? That's different than change in position. when we're talking about change in position, we don't care how much the particle traveled. All we care is how much did the
This
position
is Colin
change.
Burns.
Yes.
The design is being checked out. Thank you.
Okay. For example, everyone do this one. Okay, I'm here at the origin. Ready? I go like this. 1, 2, 3, 4. Then I go back to the origin. Then I go 1, 2, 3. Then I go back to the origin. A lot of tickets available. Raise your hand and tell me what was my total distance traveled. Raise your hand and tell me what was my total distance traveled. See what's contact. All right, there, got you. Lots of tickets on this one. What was my total distance traveled for those who were very focused when I did that? Sierra.
14,
Let me double check it here.
8, and 6.
Nice. How many got 14? 10 tickets. Good work. Raise your hand if you know this. Hey. Raise your hand if you know this.
Oh,
What was my change in position for that entire ordeal? Hands up, come on. What was my change in position for the entire ordeal? Kennedy. Kennedy says 0. How many agree? 5 tickets. Well, give me 1 or 2 that makes perfect sense. Change in position versus distance traveled. Change in position versus distance traveled. Give yourself a more. Good. Okay. Double check here, make sure I'm not forgetting something. Good. Okay. So now what we do is, this is a little different quiz. The quiz I told you was on the gold sheet, but today I cheated and gave you some kind of new notes that will count as the quiz. Some of it was from the gold, some was just things I felt like you already knew. If you did all of these correctly, and I said I would help you with this. If I helped you, that's fine. You got all these written down correctly. If you had one of the explanations that we talked about here, if you had one of the symbols we talked about, if you had the right word velocity, if you had this number, and even if you got help, that was fine, then you're going to put down a score of 10 on the clipboard for the quiz. Any questions? Please.
Will you repeat that? I zoned out.
All right.
At least he's honest.
True. If you found all these on your calculator correctly, with or without help, if you had a correct description of the meaning of this, if you had the correct symbol, if you had the correct word, and if you came up with negative 5.333, you're going to write 10 on the clipboard. Okay. If you made a mistake in one of those places, you can still write down 10. If you made more than one mistake, you really should only give yourself 5. Yeah, the quiz is 10, 5, or 0. I don't want to do all this half points. And the class is not about points. The class is about succeeding on the AP test, getting ready for college. That's what the class is about. Any questions? Okay, cool. So today the quiz just merges into the rest of the discussion. So I need you to take your calculator now, and let's see here, velocity. So everyone, please write down the formula for the velocity of this particle. Everyone, write down in your notes the formula for the velocity of this particle. Everyone, write down the formula for the velocity of this particle. Raise your hand if you have it, please. Who has it? Who has it? Come on, hands up. Who has the formula for the velocity? I'll give you another minute. 2 seconds, I should say. Who has it now, please? Show me your hands. Come on. Who has it? Go, Jeremy.
3t² minus 4.
2 points for a good try. Russell.
T squared minus 4.
Russell says t squared minus 4. Did you find your mistake, Jeremy? Don't worry. How many had it right? 2 points, 3 for Russell. We have a question. Okay, on your calculator, I want you to graph this along with the position formula that was already in your calculator. Okay, I want everyone to look at me first, though. Look at me. And one of the most important things you must do when you're using your calculator is you must window properly. Based on the information that is on the board, someone raise your hand and tell me what would be an appropriate window. Hands. Based on what's on the board, what would be an appropriate window? Look for hands. Sarah seems tentative. What do you think?
Well, I don't know. Maybe.
Just give your best shot.
Maybe like -7 to or -5 to 7 or something like that.
3 tickets. No. Listen. Being incorrect is just as good as correct as long as we know why. Here's why I like your answer when I'm giving you 3. What you're looking at is the y values. Because when we make a graph of the position, this is going to be plotted on the y-axis, as is this. So you're thinking, hey, -5 to 7. But when we make a window, we're concerned about the x-axis because it's a lot easier. The y values aren't always easy.
Okay.
Does that make sense?
Yeah.
Somebody help me. What would be appropriate y window, x window?
Oh, probably like 0 to 4.
Yeah, 0 to 4. If the problem is only talking about things that occur between 0 and 4, we want to set our window to 0 to 4. So get your calculator to show this right here. Your calculator should look like that. Need help out?
Are we supposed to do the red line too, and then,
Yours won't go. Do you have a color?
well, like the,
Oh, yeah. So I want 2 graphs. 2 graphs. I want 2. Yeah.
Oh,
So can you put the velocity one in the route?
That's what I did.
oh,
So I put the position in y1 because you already had it there, Alyssa. And then I simply put the velocity in y2. With firmness. Question? Raise your hand if this is on your screen, please. Come on, show me. Who has this on their screen? 2 more tickets. Let's drag this over here so we can talk about it a little bit. Okay, look at the board, please. Look at the board. Okay, Garen explained very nicely a minute ago. 2 more tickets for Garen. Royalty tickets. Like when they play your song on the radio, every time they play, you get some money. So now I say Garen's name, 2 more tickets. There's 2 more. Okay. Garen, 2 more. Correctly explain that with the equation for position, all we know is these are positions of the particle. We do not know how the particle traveled. Okay. However, now that we have a graph of the position here in blue, so the blue is the position graph. Now that we have a graph of the position, we can determine to actually quite a bit of detail how the particle traveled. For example, we can build a Danica's chart like this. Do this in your notes, please. X of t, v of t. And let's see, x of t increasing, x of t decreasing. Someone tell me what will belong here. Go, Russell.
Positive or negative?
Positive, negative, 2 more for Russell. So everyone look at the board. During what time period is the position, what time period is the position decreasing? Raise your hand if you can see it, please, all who know. During what time period is the position decreasing? Position is the graph in blue. During what time period is the position decreasing? Call? McCall says from time 0 to time 2, the graph of position goes down. You got that? Points 3 from McCall. Therefore, recall, knowing that the position is decreasing, what do we know about the velocity of the particle? Velocity is negative. Recall, it's pretty much common sense. I know you'll get it right. You have very good common sense. The particle we are talking about, does it strictly move left and right? Does it move up and down? Does it do both? Left and right. If the velocity of this particle, here I'm the particle now, I'm moving left and right. If the velocity of the particle is negative from time equals 0 to time equal 2, is the particle moving to the left, the right, or both? Left. How many knew that? This is them. 2, 3 from recall. So from time equals 0 to time equal 2, the particle simply moves to the left. So really what happened was, here's the particle, it just went to the left. One or two that makes perfect sense. Come on, one or two that makes perfect sense. Hiding there. 2 more points, good. Then from time equal 2 to 4, the particle comes back to the right, like so. Question. Look at the graphs. Notice, from time equals 0 to time equal 2, the position is decreasing, and during that same time, the velocity is always negative. Question. Good. Look right here, please. One person, please raise your hand. Tell me what's the y-coordinate right there. Never mind. The other was already. What's the y-coordinate right here? Let's go, Marissa. Marissa says 0. How many agreed? Points 3 for Marissa. Marissa, what's the horizontal coordinate at this point? 2. The horizontal coordinate's 2. The vertical coordinate's 0. 2 more for Marissa. Somebody tell me, what does that mean in words? Because we're looking at the red graph or the velocity graph. So what does that mean in words? Looking for someone's help. Please, Kenzie. At? Perfect. Velocity is 0 at time equal 2. Velocity is 0 at time equal 2. Here's why. Watch. Particle starts here, moves to the left. When it gets to here, it has to come to a stop so that it can change directions and go back the other way. It only stops for a split second, as we say, infinitesimal amount of time, but it must come to rest. That was on the test we just had. This is when the particle would be at rest when the velocity has a value of 0. Show me one or two if it makes perfect sense. One or two if it makes perfect sense. When the velocity is, watch me, I'll show you. 2 points for the room. Here I am, I'm moving, right? When I change direction, is there any way for me to change direction without stopping first before I go back the other way? No, I have to come to rest. That's what the particle did. Okay. Any questions? Awesome. Next thing. Let's write this on your notes, please. Write this on your notes. Write down these words, please. Write them down. Another particle has v of t, meaning velocity, equal to 10 meters per second for 2 seconds. So the particle has a velocity of 10 meters per second for a 2-second time period. If I'm a particle, my velocity is 10 meters per second. Just say it out loud. Am I moving left or right? Louder. Right. Yeah, so moving to the right, 10 meters every second. That's really hard to act out because for a human being to move 10 meters every second, that's awfully swift. Would you not agree? Like a meter is this much, right? Yeah, Usain Bolt can go 10 meters per second. He can go faster than that. Usain Bolt is. Come on. Think about it. He runs 100 meters in how much time? 100 meter, how fast do you do it? Nobody knows. No track people.
30 seconds.
How much? 30 seconds. Ooh, 30? You say 30? 3?
No, it's like, it's either 8 or 9.
It's 9 point something.
Okay.
Yeah, it's 9 point something. So he at some point in the race, he's going faster than 10 meters per second. He's really moving. Yeah, just think about it. Here's 1 meter, right? I gotta go 10 of those in 1 second. That's like
One step forward.
so 10 meters from me to the wall, maybe 10 meters? How close do I gotta get? From here to the wall, I want 10 meters. That's right? All right? I gotta cover that distance in 1 second. It's true. It's true. Because he goes 100 meters in 9.
I mean, I know it's
Yeah.
true.
But it's freaky, right? Yeah, he's not the only one. Any world-class sprinter can pretty much do that, so. Please.
It's crucial, but it's
Go.
9.58.
How it?
It's 9.58 seconds.
Oh, nicely done. So the record is 9.58 seconds for the 100-meter dash, right? Nicely done, Nathan. Okay, so look, we got a particle. Particles can go much faster than Usain Bolt. Particles moving 10 meters per second. Now it maintains that velocity. It's like always has a velocity of 10 meters per second. It's common sense, don't overthink it, just raise your hand and tell me if the particle's traveling 10 meters every second, after 2 seconds, how far will the particle have traveled? In other words, how much will the position have changed? Oh no, come on, show me your hands. You guys get me all riled up. Jake. Jake says with great confidence in his voice, 20 meters. Okay, look up, please, look up. On the AP test, you get points for units. So you have to make sure you understand how to deal with units. So we'll just keep practicing until May. When meters per second multiplied by seconds, the seconds divide out. You're left with just meters. So that particle's change in position would be 20 meters. Hands up if you knew that before he said it. Come on, show me. 2 points, 3 for Jake. Give me 1 or 2 if it makes perfect sense. Come on, 1 or 2. 1 or 2 if it makes perfect sense. If a particle's traveling at this velocity for 2 seconds, the particle's position will change by 20 minutes. If it doesn't make sense, do this, it's fine. Just 1 or 2 if it makes perfect sense. 2 more tickets for the room on the Great Ticket Giveaway, December 15th, 2016. Okay. Question. Nice. All right. Back to the graph. Look up here. Look up here. Now go to your calculator so we can see some numbers. Grab your calculator. Hit the trace button. Make sure your cursor is on the velocity plot. I type 0, it will jump the cursor to time equals 0. Just say it, please. What is the velocity of this particle at time equals 0?
-4.
Louder.
-4.
That was weak. Raise your hand if you said -4. 10 tickets. Okay. Holy crap. Told you it was the Great Ticket Giveaway. Want attention. Okay, you with me? The velocity of the particle is -4. I want to find out, look, we figured out earlier, look at the board, come on, focus, no spacing out. We figured out that between time equal 2 and time equals 0, the particle's position changed by this amount. Give me 1 or 2 if that still makes sense to you. Between time equal 2 and time equals 0, the particle's position changed by this amount. 1 or 2 if it still makes perfect sense. 2 more tickets for the room. Okay, what we're driving towards is this. Look up, come on, space it out. We're trying to figure out, for future problems of course, is what if you do not have you don't have the position. All you have is the velocity. This is all you have. You do not have a formula for the position. All you have is a formula for the velocity. Can you still figure out by what amount the particle's position will change between time equals 0 and time equal 2? Okay, now if you've had AP Physics, you know a quick short answer Although I would bet heavily that you don't understand why, because they don't typically have time to show you the why. I'm going to try and show you the why. Does everyone understand the question? Okay. I want to take velocity and figure out how much the particle's position changed. It seems like it should be easy because look at this. We just wrote. If a particle has a velocity of 10 meters per second for 2 seconds, after 2 seconds, the change of position will simply be 20 meters. 1 or 2, that makes perfect sense. Come on. 1 or 2. 2 more tickets. However, why is it not so simple in this case? Or just somebody comment. Why does it appear not to be quite so simple in the case of this particle, Mr. Jankowski?
Because the velocity is changing.
Nice. Right here, time equals 0, Garen. What's the velocity?
Negative something.
Oh, sorry.
Negative 4.
Negative 4. If I move over to like a half a second, Garen, what's the velocity?
Negative 3.75.
Negative 3.75. The velocity is not the same. We still want to get the same thing answered. We still want to find out how much will the particle's position change during this 2-second time period. So we have any ideas? Jeremy?
Do we find the acceleration?
2 points for a good shot in the dark. Won't help actually. Don't worry. Worth a try. Anybody else? Any ideas? So you're all very excited, so we'll wait until Monday to give you the exciting conclusion. No. So you're going to bring to me your tickets. So this is the last day to turn in tickets for term 2. You must turn them all in except for 100 if you'd like to keep. You can keep 100 for term 3. Everything else has to be turned in. So make sure you give me back your card. What's that? It is yeah. It's not I guess I don't really want to use that word. I think I've had physics, but we didn't use that. Most of those equations, many of those equations involve what's called an integral. Yes, we're getting that. If you're not using an integral, you're not.
You have a Q, cool.
Yeah.
I was getting an L2. And I had to transfer it. And if this
Hi.
Oh, I have to show them.
Well, I wasn't there. Was